Okay, so today we're going to talk about the Module 1 homework assignment for Section 1.2 for our Functions to Modeling course. And this is really going to be our first introduction to graphing and the graphing calculator in particular. And so we're really going to focus on the technology here. So we're going to use it to help us in a lot of ways. And I think that's one of the key things to being successful in a course like this is the sooner you can transition from the calculator being a hindrance to the calculator being a help, the better off you're going to be. This is a powerful tool that will do a lot of things for us in this class, make our lives a lot easier, but there is certainly a learning curve to get used to it and how to learn it. And so if you're having trouble with the calculator or with the homework, it's just important to let me know as soon as you can because I'm here to help. But let's get started. We're going to look at a few examples from the homework assignment, and you'll have these same problems just with different numbers, different values. But you can use these same strategies to solve the problems that you have. So this first one here, we're just asked to fill in this table. And then graph it in MyMathLab, and then finish up by graphing it in the graphing calculator. Okay, so I'm going to do all of these parts with the technology. I'm not going to do anything by hand at all. So what I'm going to do first is I'm just going to go into my graphing calculator to help me fill in this table. It's going to make it very, very easy if we know how to do it. So what I'm going to do first is go in here to y equals, okay, and then I'm just going to type in my equation for y1. So x to the third minus 3 is my equation. So I'll type in x. If I want to get a exponent, then this button over here that's right underneath the clear button right above the division sign it's called a caret. It's going to move us up into the exponent. Okay, then we'll type our 3 up there. Then it's important that you hit the right arrow because we're done in the exponent. We want to get back out to the main problem itself. And then we'll type our minus 3 in there like that. Okay, we've got it typed in, and you'll notice here, this is pretty common in math for us to have to, fill in an entire list of different things in the same function. So if I want to do that, it can do it very easily using the table features in our graphing calculator. So you'll notice the word table that's up here above the graph button. Anytime you want to get to something that's above in blue like this, you're just going to hit the second button. Yours might be a different color, but you'll hit the second button to get to those options. And then you might have to scroll around a little bit to get to where you want to go. But you'll notice here it starts at -3, -2. We have all these same integers, right? And we can just fill in our information from the table. So -3 x value gives us a y value of -30, then -11 for -2, -1 gives us -4, 0 gives us -3, 1 gives us -2, 2 gives us 5, and 3 gives us 24. Okay, and so there's our table filled in. We didn't have to do any calculations. Of course, you could have. If you wanted to do this by hand, you could have just, did -3 cubed minus 3. That's -27. Minus 3 is -30. So you can certainly work this out by hand, right? But we have the technology and we want to get comfortable with using it because it's just much quicker to do this way. And it's just the way we do math most of the time in 2021. Okay, so the next part asks us to use the graphing tool to graph the function. This is in MyMathLab. Okay, so what you're going to do to make this happen is you're going to go down to the template that's at the bottom of the MyMathLab problem, and there's going to be an option that says cubic. Let me look at what the exact wording is here. Sorry. It's going to ask you, it's going to be a cubic function, and it's going to say 4 points. Okay. And then you're just going to pick 4 of these points to choose to graph on the graph. Now, I would not pick the first or last ones because those y values are quite big. I would just pick, 4 of these in the middle, like the -1, -4, 0, -3, 1, -2, and 2, 5. And if you put those 4 points in on your grid over here, it's going to fit the curve in MyMathLab for you automatically. So just choose the option that is cubic. And the reason why we're choosing cubic is because we got this third power up here in our original equation. Tells us it's a cubic function. And then we need to give it 4 points in order to model a correct cubic equation based on those 4 points that we give it. Okay, so pretty straightforward in MyMathLab. Then the last part here is the one we're really more focused on in this class. We want to be able to graph things with the graphing calculator. Okay, so we're going to do that next. You'll notice we still have this in Y1. That's good. That's where we want it. We want to type our equation into Y1 here to get started. And then it tells you we're going to use a viewing window of X min equals -4, X max equals 4, Y min equals -35, and Y max equals 35. Okay, these are the values for our window. We need to set our window in our graphing calculator. So to do that, we're going to hit the window button here. It's the second one from the left in the top row. Okay, and then we're going to enter these values in. So X min is our -4 there. So we'll type that in here. X max is 4. Don't worry about the scales. You'll rarely have to change those. Fine to just leave them as 1 for this problem. So Y min is -35 and Y max is 35. So we'll type those in there. Okay. And then we'll graph it by hitting the graph button over here on the right of the top row. And it will fill it in and make it pretty easy to match up with our options on our paper. So in this case, we would choose option D because that's the one that looks very similar. Okay, so that's what we're looking for in a problem like that. Okay, so let's look at another problem that we're going to graph and really solve all of the questions that are asked here using the graphing calculator. Okay, so this one is about a ball that we're throwing up into the air. Kind of a physics problem. If you're going to take that class, this will be something you'll study a lot in there. But we don't really need that here. We just are going to graph it with our graphing calculator and then answer the question. So it gives us a model, S equals 100 plus 64t minus 16t squared, where S is the height in feet of the ball after it's thrown off a building, and t is the time in seconds after it's thrown off the building. So our first step here is going to be to put this into our graphing calculator and use the window that they give us to get a good picture of what's going on. So I'm going to start by going into y equals. I'm going to clear out my old graph, and I'm going to type in my equation. A little dark over there. Sorry. Let me move it over here. So we'll type in our 100 plus 64. You know, it has t as your variable in the problem. Doesn't really matter. I'm just going to use x. We can use the x variable for everything we do in the calculator. Just remember that it is time in this particular problem. Plus 16x. And then to get the squared, you could do it with the caret too, but you could also just hit this little x squared button over here to get that second power on there. Okay. So there's our equation typed in there. So our next step then is to set our window. So I'm going to go into the window button, which is the second one from the left over here. We'll type these in. So 0 to 8 is my X min and X max. That's what this means when we have this these values in the brackets. The first one are our X min and our X max, and the second one is our Y min and our Y max. These are intervals that represent that window that we want. And so we'll set it up like that, 0 for X min and 8 for X max. And then these values here will be our Y min and Y max. So 0 for Y min, 200 for Y max. Okay. So then we'll graph it. Oh, whoops, sorry, typo there. Should have been a minus. Okay, so we'll correct that. Go to our graph, and there's the picture that we're looking for. And it makes sense, you know, if we're on top of a building, we throw a ball up, it goes up for a while, and then it starts to come back down, and then this is the point where it hits the ground. Okay, so we've got our graph done. So the next one asks us to find the height of the ball 1 second after it's thrown, and then again 3 seconds after it's thrown. So really what that's asking us to do is these are times, which are our t's in this equation. They want us to plug this 1 and this 3 in for t. And of course, you could do this by hand if you wanted to. You just do, 100 plus 64 times 1 minus 16 times 1 squared. and just put that in your calculator and that will work. But that's not really what this lesson is about to me. This lesson is about doing things as much as possible in the calculator. And even though we can do this by hand and it's not that hard, it's even easier to do in the calculator. Let me show you what I mean. If I just hit the trace button here, okay, and I just type in the number 1 here for my X, it's just going to give me the Y that goes with that. Okay. So as long as you have the correct point in your window, in your viewing window, you can just type it directly in there and it'll calculate it for you. So the height of the ball 1 second after it's thrown is 148 feet. So again, you'll have this similar problem to this in your homework. Your numbers will be different though. So don't expect to get the same answers that I do. Okay. And then similarly, we can just hit the trace button. We want to plug 3 in for our time and calculate it out that way. And we did get 148 there. Okay. Our last question here is, are the two values equal? We can see that they are. We got 148 for both. And we want to think about whether that makes any sense in the context of the problem. And the answer is sure it does. What that means is after 1 second, our ball is going up. So we're at this point, right? And then we hit that top, that peak, we call that a relative maximum. And then we start coming back down and we hit that same point again at 3 seconds. Okay, so we just hit that same point on the way up at 1 second, on the way back down at 3 seconds. So it's totally reasonable in the context of this problem. Okay, so the last example I wanted to work for this section 1.2 is one like this. We're given a function P that gives us the percent of households with internet access as a function of T, where T is the number of years after 1995. This little phrase right here, this is something we're going to see a lot in this class. And this is something that basically every business in the world does when they build models. No one wants to plug 4-digit numbers like 1,995 into their function. So what we do instead is we take the first year that we're interested in. And in this case, the first year that we're interested in is 1995, and we make that the year 0. Okay. And then every year after that, so 1996 would be a T value of 1. 1997 would be a T value of 2. 2001, we would just take 2001 minus 1995. We would get a T value of 6. We can just scale back our years in order to make the values that we plug in here for T much, much simpler. It makes everything about your models easier to work with. So it's super common in the real world to do this. Okay. So our first question asks us to find the values of T that corresponds to these 2 years, 1998 and 2001. So really, we're just going to subtract 1998 minus 1995, our first year. So our T value here would be 3. Makes sense. 1998 is 3 years after 1995. Okay, similarly, we just do 2001 minus 1995, we would get 6. So our T would be 6 here. And that makes sense as well because 2001 is 6 years after 1995. Okay. Now they ask you a similar question kind of in the opposite direction. It says P equals F of 7. Remember, this value that's inside the function notation here is our X value, or our T value in this particular case. Okay, it asks us what year are we talking about here? Well, remember the context. T is the number of years after 1995. So we want to figure out what year we're really working with here. We just want to take that 7. We want to add it to our starting year of 1995. So F of 7 is really talking about the year 2002. Okay. So next we're asked, what is F of 7? This is another one it's quite easy to do by hand. You just plug that 7 in for T up here. You would just do 3.89 times 7 plus 6.15 and just work that out if you wanted to do it by hand. But again, to me, this lesson is more about getting comfortable with the calculator and working that way. So that's what I'm going to do here. I'm going to go into y equals. I'm going to type in my original function. So 3.89, my variable's t. I'm just going to type x plus 6.15, hit enter. Okay. And then I just want to plug t into that. There's a few ways that I can do that. I can just go into the graph. Okay. I can see my graph on there, and I can do like I did in the last one. I can just hit the trace button and then type 7 in. Okay. And that'll give us the value that we're looking for here. So 33.38. Okay. I could also go to my table, scroll down till I get to 7. I can get it that way as well. So the point here is that we can do a lot of these calculations with the calculator, and it can really save us some time, right? This calculation is so simple, it maybe wouldn't have saved you much time for this particular problem, but many of your models will be much more complicated than this, and the technology is a huge time saver in that case. Okay, so finally it asks us what Xmin should we use for the viewing window and what Xmax should we use for the viewing window. We're interested in what happens from 1995 to 2005. Okay, so we've got to keep in mind the context of the problem here. T is the number of years after 1995. So in 1995, we are 0 years after 1995. So our first X value is going to be 0. In 2005, we are, well, subtract 2005 minus 1995 will give you 10 years. So we're 10 years after 1995 there. So 0 to 10 would be our window that we could set. Okay. And that can be really useful. Like the graph I've got here, it's got everything on there, but it's not super useful. It's just so flat. And we have all of this part of the window here that we're not interested in. This can be really useful to get a better picture for what's going on. So what I'm going to do here is I'm going to use this to set my window. I'm going to make my X max 0. I'm sorry, my X min 0, my X max 10. And then I'm not going to pick my Ys. I'm going to let the calculator do that for me. This is something that's really useful. We're seeing here how 200 is way too big. In fact, it doesn't make any sense to do anything over 100 since this is a percent of households, right? It's impossible for this to be bigger than 100, but I'm not even going to try to pick these. What I'm going to do instead is I'm just going to let the calculator do it for me by using the zoom menu here. There's lots of powerful tools in here, but the one that I use the most is I like to use the zoom fit option. If you scroll down a little bit, option 0 here is zoom fit. And what this does is it tells the calculator, I gave you X values. You pick Y values that are appropriate for those X values to show me a good picture of the graph. And it's going to fit it right in there. Okay, now this is a line, and so that we got what we expected there. We know it's a line because we just got that single T in the original problem, but we can see everything, and it uses the graph window perfectly. And 0 to 10 is still the values that we're looking at there. Okay, so hopefully that's enough to get you off to a good start in this problem. If you're struggling with the concepts here or with the calculator in particular, it's important that you let me know as soon as you can. I'm happy to work with you and try to get you cleared up on those. So y'all have a nice day and let me know if I can help.